In this part of the video, we are going to talk about the different prominent neural networks. Um, we also will talk about the different use cases that can be solved using deep learning and the different kind of neural networks that can be leveraged. So we'll talk about the mapping, and we'll also talk about how the neural networks in general work, the different aspects, the different components. So starting with artificial neural networks, I mean the different types, the prominent one. Let's start with feed-forward neural network. So in the beginning, we had discussed that what is a neural network. So it starts with the input layer, then there are middle layers, and then there is a output layer where the decision is taken. So feed-forward neural network are they will flow in one direction. So in a way, input will be taken in the input layer, hidden layers will process the data, and then the decision is taken in single go. So there is no back pass that is going to happen. Uh, Convolutional neural network is a very popular one, and very powerful one as well. So this is typically used for images, videos, right? Anything which has got a grid-like structure, right? Uh, and as I said, that this is one of the most prominent model which is available, and it is very widely used. And any kind of implementation that you will read, or any kind of book on deep learning that you will go through, you will see a lot of reference on CNN. So, and primarily because it's so powerful. Deep reinforcement learning, we have spoken about reinforcement learning. We discussed that in the machine learning algorithms as well, right? And as we know that reinforcement learning works on rewards and penalty. The same concept is applied in the neural network as well, and they are typically used when you are going to train a particular robot, or you are in the gaming industry, right? And they're far more impactful as compared to what we have seen in the models which exist in machine learning. Again, they have got their own nuances as well. Those needs to be controlled. But in terms of when I say powerful, when I'm referring to how in terms of accuracy, right? In terms of performance, um, how much you can depend, how much you can rely on the results which are given by the deep reinforcement learning. Then we have got recurrent neural network, wherein if you're dealing with the sequential data. So say for example, if you have given a sentence, um, I am learning AI, right? So if you have if you are using RNN, the data will be passed sequentially, right? So it will pick up the first word, the second word, and will do some kind of predictions. It will try to make meaning out of it. It will try to do the summarization and all. And in case if you are dealing with any kind of time series related problem, um, say you are doing a prediction on of the stock market, right, for a particular script, or maybe you are doing a prediction of revenue of a particular organization. Revenue is again a time factor thing, so it can be annual, it can be measured at annual rate, it can be measured at monthly, quarterly, right? And accordingly the times the forecasting can be done. And when the forecasting is done, you can use RNN neural network. Okay, so moving on, this is where we have mapped the different types of problems, and what are the deep learning models that can be used, that can be leveraged to solve those. So let's talk about the first problem type. In case if you're dealing with images and vision, right? CNN, as I said, is the popular choice, right? And some of the example use cases is you are in case if you are detecting the diseases based on any kind of imaging. It can be X-rays, MRIs, and all. Facial recognition, typically used in different stores, or maybe wherever the biometric data is supposed to be used. Self-driving cars. So these are the examples where the images and vision, you use them to take a decision. And how it works on the different visual features, like it try to understand the edges, the shapes, the objects, right? Just like the way the human process the different patterns using their eyes, right? So here CNN comes into the picture. Let's move on. When you're dealing with text and language, say you want to do summarization, you want to do translation. That's where uh, RNN LSTM transformer comes into the picture, right? Uh, and typical example use case are chatbots, translations, summarization, right? They and how they works, they typically understand the pattern in the word sequence. They try to understand the grammar, the meaning of words, and try to put some sense into it. In case if you're dealing with sound and voice, right, that's where again the CNN or transformers comes into the picture. And when you're dealing with examples such as speech to text, emotion detection, virtual assistants, and you know that virtual assistant are quite prominent now, right? In fact, speech to text is almost everywhere. It is there in the chat GPT as well. It is there in Word. It has been there in Word since long, right? Uh, Emotion detection is something which is now available in many visual word editors. Uh, and they learn how sound waves form, the association between the words and emotion and the sound waves. Right? When you're dealing with a time-based data, that's where the RNN comes into the picture. You can forget the CNN part. Maybe you can focus on the RNN more. And this is something which we discussed, that in case you were doing any stock prediction, energy demand forecasting as well. I think this is one of the area which is very popular, and I think it's widespread used. And RNN is implemented to do the energy demand forecasting. And they learn on the basis of how things change over a particular period of time. They brought in seasonality. um, they try to understand the patterns and the different times. I mean, it can be a particular time period in a day itself, maybe the morning hours, the evening hours, right? And if you can recall, we did the flight prediction where we differentiated that there are flights that are taking off in the morning hours, that there are flights that are taking off in the noon and the evening one. And we were figuring out that the evening flights generally they get impacted and they are delayed. When you're dealing with a tabular or business data, and so you can apply machine learning algorithms, but we have seen that when the data increase, um, machine learning algorithms, they do not improve beyond a point, right? But you want your use case is such that you want these algorithms to improve, or the forecast to improve. You are expecting a higher performance, right? That's where again you can apply deep learning models, and feed forward neural network is a choice for that. Say for example, here you have to do predicting of customer churn based on different parameters. And churn prediction is very critical, because cost of acquiring a particular customer is very high, and that's why the organizations are very sensitive towards customer churn, right? And then credit scoring, loan approval, right? So these are some of the example use case. And they work on the basis of the hidden patterns in the data. uh, they try to figure it out, and uh, try to understand, okay, in case if a behavior has been demonstrated, say for example, um, if you're dealing with customer churn, identifying the patterns with the customers who have actually exited the system, right? They try to understand similar kind of patterns with other customers, and try to predict if the situation continues, or maybe when the renewal will come, or maybe abruptly this customer can move out. So this is the overall mapping between the uh, different deep learning models and the different use cases. Let's move on. So this is a functioning of a neural network, right? So if you can, yeah, let's read this slide from left to right, right? And these are the different inputs that we have that are going into the network, and we have created multiple layers. And there are some weights, there are some bias, which is we are plugging in, and at every decision there is some mathematics, some kind of decision making is taking place. uh, Activation is taking place where it is deciding whether a particular neuron, right, this particular signal should be processed and how it should be processed, right? And finally the decision is taken. Now, as we know that these decisions are nothing but predictions, so there will be always a possibility that it may not be accurate, right? So we need to compare with the true values. We need to understand the difference between the true values and the prediction, right? And that's where the loss functions comes into the picture, right? So and you try to understand the what is the loss, and you try to minimize it. And when you try to minimize it, first you qualify how impactful is the loss in the loss score, and then you go and uh, um, try to adjust the weights and bias, right, using the optimizer function. So optimizer will decide, okay, how much weight should be adjusted, how much bias should be updated. Once this is done, again the forward propagation will take place. Again this network will get activated with revised weights, with revised bias, and then there will be another prediction that will happen. Again it will be measured against the true value, right? And there will be some loss that will be associated. So this entire cycle will continue till the moment, uh, till the point in time loss function is not minimized, right? And once the function is minimized in a way, the model has learned, the model has optimized to the extent it could have done it, right? And this is how the once this part is done, it is good to go into the next step, whether you want to deploy it or you want to drop it because it's not good enough. Those are the decision that you can take, but the training part is done. So this is a brief functioning of how the neural network works. Thank you so much.